Well, welcome everybody to the presentation today for facilitating the digital transformation with CAD assets and visualization. That's a big mouthful. You might be wondering what in the world we're going to cover today. It sounds like Rusty's going to talk about everything the factory design utilities can do. That's kind of what I'm here to talk about today, is all the ways that the factory design utilities can help you facilitate the transformation to a digital version of your factory floor. My name is Rusty Belcher. I am a solutions consultant with IMAGINiT Technologies, and I have been using the factory design utilities for really since before they became public, so almost 12 years now. And I've worked directly with Autodesk in the past to develop a lot of the training content for the factory design utilities, and I just finished working on a project with them again to update some of the training material for the newer releases of the application. Well, we've got a lot of ground to cover today, so I want to dive into it. I think when we were putting these presentations together, we all looked at each other and said, wow, this is like teaching at Autodesk University. And every time I teach an Autodesk University class, I'm required to have 4 bullet points at the beginning of the presentation that tells the audience what we'll be talking about. So in today's presentation, we're going to try to cover the innovation that you can make with process modeling for factory design. We're also going to take a look at incorporating reality capture into your digital facility, embracing factory utilities for your digital development of a factory layout, and the benefits and rewards of visualizing the digital factory floor. Now, we're going to start off with this idea of the innovations with process modeling for factory design. I have to tell you, I think many of you know who are on the call today, you're familiar with the term Industry 4.0. It is the idea that we are currently in the midst of a fourth manufacturing revolution, and we are dealing with connected machines, connected processes, connected workforces, connected customer bases like never before. Everything is connected to everything. And when you come up with a new process or a new product, it is almost inevitably it's almost inevitable that you're going to have to map out the process you're about to produce in a very strict and direct way. A lot of times when we are dealing with processes, we want to jump directly into our traditional 2D or 3D CAD tool to solve the problem. And I don't know whether we realize it or not, but we jumped over a D. We absolutely jumped over the 1D. Now, some of us who have been around design for quite a while might think of 1D as those old napkin sketches, but I have to tell you, those old napkin sketches came in handy back in the day. But no, I think in today's world, 1D refers to some digital way for you to define an idea or a process. Think of modern flowcharts, if that's what you want to call it. We are going to take a look at process modeling and how that should really be one of the first things that we approach in the overall process of laying out a factory design. Well, process analysis involves reducing your process to 5 or 6 different options: a product option, a process option, a buffer, a product, or an operator. Now, what we can do with process analysis, which is a tool from Autodesk, is we can bring in a rough outline of our factory facility. And then we can start defining our process in a unbelievably advanced flowchart editor. So I have a couple of feed lines here. I have a couple of feeders, source objects coming into my system. They run into processors where something happens to those objects. Then they are put into buffers for some temporary resting time while they wait for other processors to open up. And at the end of that, they're going to feed into a product count. Now I can then run the process and simulate it, and then I can tweak the numbers for the input, the time it's taking for the processors, and the overall time it's going to take for these to produce a particular quantity of objects. Now, once I have that process dialed in, then I can take a look at the next step, where I associate a 3D model with each of the nodes in this flowchart. When I'm ready, I click Go, and it generates an AutoCAD drawing for me, where each of the nodes is now represented by a full-scale block inside of AutoCAD. So here I have pretty much addressed the 1D. We used the process analysis tool as part of the factory utilities to generate a 2D AutoCAD drawing of the process that we have set up. Now, process modeling is a science in and of itself. And the Autodesk Factory Utilities give you a very nice tool, the process analysis tool I just showed you. It does a very good job. It's an entry-level process analysis component, but there are more advanced process modeling tools that are out there. And honestly, the better your process chart is up front, the more accurate and the better your factory layout will be in the end. Now, the discipline of defining a process is called discrete event modeling. It's a simple and versatile way to describe and analyze a dynamic system. Now, the word discrete, I want to make sure we understand which word I'm talking about here. I'm talking about D-I-S-C-R-E-T-E, individual, separate, and distinct. We want to reduce a process to its discrete input values or its discrete levels. We're not talking about trying to talk quietly so that we don't offend somebody. No, we're talking about analyzing a process in terms of its discrete points. Now, discrete event modeling happens all the time, not just on factory floors. If you've ever been to an emergency room and ever wondered what is the workflow when you show up and you go to the nurse and she evaluates you, she puts you in a triage. How sick are you? How many beds are available in the back? What kind of illness do you have? Where do you go from the sign-in station and what doctors do you see? All of that has been modeled out with discrete event modeling software or process simulation. Computer network traffic is the same way. Bank teller services, supermarket checkout, and of course, mechanical manufacturing workflows. Any of you ever get on an airplane at an airport and wonder why you have to jump through the number of hoops you have to jump through to get on the airplane? All of that has been mapped out over and over again to make it as efficient as possible. Now, when it comes to airplanes, I know that you probably want to grit your teeth and say, really, I think airplanes could be a little bit better. But I promise you, they've spent a lot of time trying to figure out how to get you on board the plane and off in as efficient manner as possible. Well, if you're using the factory design utilities and you want to take a deeper dive into process simulation, there is a tool that you can purchase called Process Simulator, the Autodesk edition. This is from a company called ProModel. You can actually get to this through Inventor. If you go to the Inventor App Store, you can actually go out and sign up for a free trial of the Process Simulator tool. Now, where our process analysis tool that's part of the factory utilities is a fantastic tool, it is a basic level process simulator. But if you want to go with a full-blown version of process simulation, you certainly want to check out the ProModel tool. You might ask yourself, what's the difference? What could possibly be the difference? Well, let me ask you a question. Think about any process you have on your current factory floor and go down to one of those very discrete events that's happening. And I'm going to ask a very simple question. How long does that event take? In the Autodesk version of process analysis, we get to input one answer. Now we might say, you know what, it takes varying degrees of time. Sometimes it's 8 seconds, sometimes it's 3 seconds, most of the time it's 6 seconds. But we have to plug in one value. And if we start to average all of our inputs that way, because we can only input one value, we're going to reduce the accuracy of our simulation. On the Pro Model side, when it asks you that simple question, how long does this take? Well, you can actually answer in the form I just mentioned. You can say the majority of the time it takes about 6 seconds, but every once in a while it takes 8 seconds. Sometimes we can get it through at 3 seconds. And what the tool will do is it takes those numbers and it doesn't just run one test. It runs hundreds of tests, hundreds of individual scenarios where it takes those random values and applies them to your model so that your process model becomes more accurate, a more accurate depiction of what's going on your factory floor. True process simulation must account for randomness. It must account for interdependence. It must take into account time variables and various distribution-based models. It needs to take into account service downtime, resource allocations, and logical arguments for capabilities. And what I mean by that is what if statements, or if this, then this. And of course, your workforce schedule. How many people do you have calling out sick on a typical day? The Pro Model version of Process Simulator takes into account all of that. Now, the benefits of process simulation. Listen, if you're looking online, there's a reason that the text on the slide is so small, because there are so many benefits of analyzing your process and modeling it up front. It's incredibly valuable. You gain a true understanding of your dynamic system, and you start to do predictive analysis and not reactive analysis. You start to discover system latencies. You have the opportunity to resolve resource utilization issues. You're going to uncover bottlenecks. But overall, you should be able to maximize the production capacity of your line or process. You should be able to increase your revenues, minimize defects, and minimize cost. And at the end down there, there's that word. This becomes a virtual factory run in a flowchart format where you can start tweaking the numbers and coming up with different scenarios to see how your factory floor will react to upcoming changes. It's one of my favorite quotes up on the screen, and it kind of makes sense to share it here. And if you're a Back to the Future fan like I am, you remember at the end of Back to the Future when Doc Brown comes down and says, hey, your future hasn't been written yet. No one's has. So what you want to do is do everything you can to make sure your future is a good one. Process simulation is the way to do that in your typical factory layout. Now, the next topic I want to cover is incorporating reality into your digital factory. You know, many of us start off life in what we call a brownfield situation, where I've got tons of things out here that, you know, exist today, and I need to get them in the computer so I can add the new stuff that I want to build into my system. That's where reality capture comes in. There's all kinds of ways to capture reality. You can hook up a camera to a drone, and you can go up and use a tool called photogrammetry to stitch, impossible shapes together to make a digital representation. Photogrammetry it's available to everyone that has an iPhone. You can start using photogrammetry tools today. But you can also take into account laser scanners. Now, laser scanners are more high-end. It's a laser on the end of usually a tripod, and this laser is going to shoot out millions of lasers per second in order to record a particular area. Now, whether you use the laser-based LiDAR method or whether you use the photogrammetry method, this idea of going into the world, capturing real-world objects and then bringing them back and getting them onto your computer gives you a whole new workflow to develop your factory floor. Reality capture techniques are incredibly commonplace. I mentioned your phone earlier. Most of your phones can do photogrammetry today. If you just have your camera phone and you take enough pictures of an object, there's usually going to be a photogrammetry app that you can utilize, or believe it or not, you can use one of the factory utilities, Recap Photo, if you want to come onto the Autodesk side and generate a photogrammetry model. There are tools to do that. But many of our phones have sensors on the back of them now that read spatial orientation. That's how your phone looks at your face and recognizes you as being you. And people are starting to take that that broadcast that your phone makes and starting to develop reality capture content based on your phone scanner that you're carrying around every single day. So I want to take a quick look at how reality capture can be utilized in a brownfield scenario for a factory layout. So here's a portion of a point cloud. And remember, point clouds are just points. This was done with a laser scanner. Now, the factory utilities have tools in there that allow us to deal and work with point clouds. So I can take them and clean them up and get them to the nicest position possible for the work that I have to do. And I'll be honest, it all comes down to eliminating as many points. In this case, I don't need the factory floor here. So I'm going to take away those millions of points to make the point cloud a little bit lighter so that I can use it easier inside of Inventor. Now, I might also want to view the data in an orthographic mode. That's amazing. To view reality in an orthographic mode makes things like cleaning up the floor here and getting rid of everything I don't need extremely easy. Another tool that's essential is establishing a coordinate system. The recap tool here is being used to establish a 0, 0 point for this model, and we're going to have our digital model inside of Inventor correspond to the same 0, 0 point. It's really important in any kind of layout process that all of your team members utilize the same origin point. Now, once my point cloud is cleaned up, I can then export it easily over into an Inventor, my CAD tool, and then I can insert it at the origin. So here is this reality capture populating into my layout space, and it's lining up perfectly. Now, there are tools inside of Inventor that help us to deal with point clouds. The box crop tool allows me to define points that I want to keep and points that I want to hide. So I can remove the roof of this cloud immediately and see up underneath of it where I need to place my assets. Now, speaking of assets, this is the first time you're seeing the factory utilities and the asset browser, which lets me go in and hunt up a number of particular, in this case, CNC machines, and easily populate them on my floor in context of reality. Really nice to be able to place my equipment knowing that I'm not going to foul anything because I've got reality recorded and I'm using it inside of my CAD tool. Now, you're going to hear me say this a number of times in the presentation, but you can scan anything. That forklift is actually a point cloud scan that I had. So instead of modeling the forklift, I just took the scan and used it as the asset. But now I've got my hybrid environment of point clouds and solid models ready to go that represent the future state of this existing layout. I hope you see how reality capture was essential for this particular process. I wanted to highlight a few points before we move on. Reality capture, it's amazing to take reality and to display it in orthographic mode. You know, we walk through reality all day long in perspective mode with depth of field or depth of vision. The things that are further away from you are smaller than the things that are closer to you. But we can take reality and we can put it into orthographic mode. This might be useful if you just want to trace the outline of the facility that you're working in. Take your scanner out, scan it, bring it up into the tool, and just generate an orthographic picture of the room that you're working in. Might be perfect for that, but we can go further than that. I also hope you took note of how we could establish the origin point in reality. So if, again, I mentioned it earlier, it's very essential that all of our team members on this project work to the same origin point. If you're in 2D AutoCAD, or if you're in 3D Inventor, if you're in Revit, we all want to agree where 0, 0 is. Well, now I can go out and record reality and establish where 0, 0 is in that model as well. Once the scans are imported into the Inventor environment, they will report to the 0, 0 point, and then I can start applying or adding my assets in context of reality to flush out the placement of machines in this brownfield scenario. Now, I mentioned very quickly earlier that you can use your scanner to scan equipment. You know, maybe you don't have a number of 3D modelers that are just sitting around with nothing else to do. You know, you don't have time to commit to modeling everything in 3D with extrusions and revolves. Well, listen, if you have a scanner, you can go out and scan a piece of equipment like this little generator here, and then bring the scan in, draw a little 2D footprint underneath of it like I did here, and then this becomes your asset to use in the future. Between you and me, I generated this scan with my cell phone. The scan you see here of the generator is a result of photogrammetry. This allows you to take any real world object and convert it into an asset that can be used over and over again. Now, we're going to talk about assets in the next chapter of our presentation, but I need you to understand assets. If you're at all an old AutoCAD user, think of the terms as blocks. But imagining going out into the world and finding a real world object, turning it into a digital block so that you can use it over and over again in any upcoming project. That's what reality capture brings to the factory layout solution. All right, I want to take a look at our third topic, and this is embracing the factory utilities for digital development of a factory layout. So we're finally going to get to talk about what these factory utilities are, where you can find them, where you can get your hands on them. The factory utilities are really an add-on, you'll see, for many of the Autodesk applications that are part of the product design and manufacturing collection. Their overall goal is to allow you to design, visualize, and simulate any space. Typically a manufacturing space, but it doesn't have to be a manufacturing space. We want you to be able to explore all your possible design ideas. We want you to be able to visualize projects to where there's no doubt in anyone's mind what's going on. And we want you to be able to simulate the real world applications of your layout design. Another way to put this is that the factory design utilities are the digital prototyping solution for factory design. I think many of us have been working with CAD long enough to have lived through the era of digital prototyping. I think we all know now how valuable it is to be able to develop an object on the computer first. We can go through and develop that object and try different material types, run different analysis on it, try to bend it, crush it, heat it up, and we can define what is the optimal design before we ever commit to an actual prototype. Well, why should factories be any different? I've already mentioned the fact that we can start off with a digital concept like a flowchart, the process analysis tools. We can cover all the designs or all the necessary needs for 2D and 3D development of drawings or models. We have simulation tools that we can put parts into motion, or if you want to bend parts and twist them, we have tools to do that too. But your documentation, right? Once you have your full digital factory, once you have that digital counterpart of your actual factory, you can then generate all the drawings you will ever need with the tools in the product design and manufacturing collection. And you'll also be able to visualize any potential change in that factory and see how it will impact your current factory layout for the good or for the bad. Real quickly, the product design manufacturing collection is the collection that includes the factory design utilities. I think a lot of people look for the factory design utilities on the architectural side, but they are entrenched on the mechanical side of things. What's included in the product design collection? Well, real quickly, there's more tools in it than what I have here on the screen. But I think the premier 3D modeling tool from Autodesk for manufacturing is Inventor. So I think Inventor is pretty much the star of the product design manufacturing collection. Fusion is here as well. For 2D, they give you every AutoCAD that has ever been, really. You have AutoCAD Electrical, plain vanilla AutoCAD, AutoCAD Mechanical, AutoCAD Architecture. If someone on your team is responsible for drawing the walls and windows of a space, they really want to look at AutoCAD Architecture and see how easy it is to generate that information inside of a 2D tool like AutoCAD. Navisworks is a tool you'll hear me talk about later on the visualization side of things. Recap is the tool you saw me use earlier with the point clouds. All of these tools are clustered together and sold as a package called the Product Design and Manufacturing Collection. One of the tools inside of this collection is the Factory Design Utilities. The Factory Design Utilities actually enhances the AutoCAD application, the Inventor application, and the Navisworks application, so that you'll have additional commands inside of those three tools that you wouldn't have otherwise. So for 2D work, the Factory Design tools hop into AutoCAD and enhance AutoCAD. For 3D work, the Factory Utilities enhance Inventor. For digital mock-up of the overall facility, the Factory Design Utilities enhance Navisworks. Now, there are other tools that play into the overall factory layout process. If you want to do high-end photorealistic rendering, 3ds Max is there. I mentioned Recap already for reality capture, and I've also mentioned process analysis for that 1D flowchart version of your factory layout process. So what challenges do factory designers face? A lot of this is, I'm sorry guys, I know I'm preaching to the choir, but you are here because, look, this is a challenge. Laying out a factory is a challenge in this day and age. Traditionally, factories were laid out in a top-down only approach, strictly 2D top-down. And there are still people today who use the factory design utilities to create these elaborate 3D models, and at the end of the day, they generate a traditional top-down view. There's a workflow for that, and it works fine. But quite often, when it comes to greenfield or brownfield projects, you end up having to do a lot of free work because you have to do some work in order to just make a bid on a particular job or a proposal. Working in traditional 2D can make it quite difficult to collaborate with people who are not 2D centric. It's an inefficient design practice. It incurs a high change order cost. It's very difficult to find clashes in 2D, and you're unable to profitably implement any kind of lean manufacturing techniques with a traditional 2D approach. Well, the factory design utilities were designed to answer all of those questions. You're going to take the power of not just AutoCAD, but the power of Inventor, Navisworks, and all those tools that are part of the product design manufacturing collection, and you're going to bring them to bear on the factory layout process. You're going to have automated bidirectional workflows, which really means if it's a 2D process, work on it in 2D. If it's a 3D process, work on it in 3D. Work on it where it makes sense, but understand that it's the same project, whether you're looking at it in 2D or in 3D. You're going to have a number of visualization tools that to bring to bear on the project that really give everybody the same vision. We all can be working towards the same goal. Cloud-based assets. You're going to see assets here in a moment and how they work. The fact that you can develop your own assets and an asset-based building environment where parts fit together automatically. The overall goal, we want you to win more business. We want you to improve your bidding process. We want you to be more profitable. We want you to be able to meet compressed project schedules. We want you to be able to easily adapt to changing business requirements. And we want you to be able to collaborate easily and more effectively with all the people on your supply chain and the partners you collaborate with. I think many of us who have used CAD for a long time have been looking for what I call the Holy Grail. And I'll name it, I'll be glad to name it. I have always called this Lego CAD. I want my CAD system to work like these little bricks that we used to play with when we were kids. Well, I'm here to tell you that the factory design utilities do this. They bring this kind of workflow to the factory layout process. Let's take a look at this. I want you to see these layout tools, the factory utilities in action. So here I've got Inventor opened up. I've dropped in a few assets already, but I'm going to use one of the utilities to bring in the 2D drawing of my facility so I can work in context of the 2D footprint, and I can start adding assets in context of the existing assets and the other footprint of the building. I can move parts around and snap them back together, again, just like those building bricks I just mentioned. And the assets have so many types of controls for parameters. Here, there's an iLogic form that allows me to swing the robot arm out to a particular position. And I have a different head that I can install on the arm for packaging. You'll notice how these two robots over here snap to the bases automatically. And I can snap different arms up on them very quickly and easily. Again, think of Legos. That's how your CAD system should work. Here's a packaging machine from another CAD application like SolidWorks or Pro-E. Doesn't matter. I can bring in this information, have it land on the floor automatically. I can position it where it needs to be and utilize it right alongside of my other factory assets. At any given time, I can click a single button and give you that traditional top-down 2D AutoCAD drawing. But I can also continue to do my documentation inside of Inventor, where I can give you the top-down view, but then I can also give you an isometric view that includes a bill of material and balloons for all the components in our design. When it comes to documentation, you have so many options with the factory design utilities. Now that's just a glimpse of what those utilities can do. Trust me, in this presentation, you're going to see some more coming up. Now those assets we talked about, there are really two kinds of assets. They have static assets that do not change shape and size. If your assets are static, you can download them from anywhere. You can go up to GrabCAD and get a forklift. You can go out and get a SolidWorks, get a pallet, or you can go online to maybe like MasterCard, or I don't know where you would buy office furniture or printers. But if you can find the models for those, you can bring those in and use them as is, as assets. If your assets are dynamic, in other words, they change parameters like length, width, and height, you're going to want to design those specifically in Inventor so that those parameters are available when you place the asset on your factory floor. Now, I want to finish up with the last topic today, probably my favorite, and it's most people's favorite. It's the benefits and rewards of visualizing the digital factory floor. You know, I think it's important for all of us to understand that every project reaches a point where it cannot proceed until everyone involved agree on the common vision. You know, a lot of times we have concepts, we have these great ideas, but we can't get them off the ground because I can't get everybody on board with the vision that I have. Well, there are so many visualization tools available with the factory utilities. We're going to take a look at Navisworks. We're going to take a look at a tool, an add-on tool called Twinmotion that's not part of the utilities. But listen, if you need to make high-end videos, if you need to make walkthroughs, if you need to basically do what I call desktop VR, the utilities have you covered. On the left-hand side, I think you see a class I taught at Autodesk University where they're playing basketball on the deck of an aircraft carrier, or they're having a football game in the middle of a NASCAR racetrack. On the right-hand side, you see a number of individual renders of several different compartmented add-ons we've done to the factory lines throughout the years. All of this is done with the tools that are inside of the factory design utilities. I mentioned Navisworks, and a lot of people have the factory design tools and they never install Navisworks. They just don't know what it's used for. Well, Navisworks is really your digital mock-up solution. It allows you to take models, not just Autodesk models, but models from anywhere. I like to say if it's 3D, you can bring it in and use it. So Inventor, Step, Aegis, Aces, SolidWorks, all of that, you can bring them together and make one massive version of your design. These designs quite often would exceed what your typical CAD solution would be capable of. Now, once you have this digital mock-up, you can do things. You can start expressing processes visually. Here on the left, I'm just moving a simple forklift to do some material handling. On the right, I'm picking up a missile and moving it on board ship towards a magazine or towards a launcher. Once I have these 3D sandboxes, I can go in and play and document any kind of procedure I want. On the left-hand side, you see how Navisworks is being used to find clashes. That's one of its big bonuses. You can use it to find and define clashes very easily. On the right, you see the timeliner. This allows me to establish a production schedule where pieces are going to come into a confined space in a particular order. And that way I don't have all the parts arrive on the same day and everyone be tripping on each other the entire time we're trying to build out a particular space. Navisworks is responsible for both of these visualizations. Yes, one of them is a traditional factory layout. The other one is a shipboard application of the factory design utilities. They're both possible. Now, one of my favorite additions to the current state of the factory design process is a tool called Twinmotion. Now, this is not an Autodesk tool. You'll have to add this one to your repertoire, but this is actually a tool from Epic Games. It's believe it or not, it's used to create gaming levels. But what a lot of people have done is if they've seized upon it to do visualizations of their overall design. Here on the video that's playing, I simply export a simple FBX from Navisworks, import it into Twinmotion, and it already looks 100 times better than it did in Navisworks. But as I come in and walk through, I can add materials, real world materials to my design. When I built this building ages ago, I envisioned a light blue skylight. I also want to turn on all the lights in the design and have them glow a little bit. These things are built right into this particular tool. And if I grab my joystick and I can go over here and out here to the pond that's on this particular facility, I can go over here to this pond that's on this particular facility and add a water texture and actually see the water ripple as I walk away. Now, I'm also going to step in and add another level of realism to this design. I'm going to add animated characters to my design. And again, this is all built into Twinmotion. I can bring in a worker, drop him off here, and unless I give him something to do, he'll just stand there and nod back and forth and wait for something to happen. It's that easy. It's simple drag and drop. Here, I'll walk over here to this platform and drop off another character. The characters have their hard hats and safety equipment, and they're ready to go. All I need now is for boxes to start flowing down the conveyors, and believe it or not, Twinmotion can help you do that too. Now, Twinmotion it's really a new tool for the factory design community. Believe it, trust me, this tool is being monopolized by the people on the architectural side of things. But I was able to get a copy of it, and just amazed at how nice it can make my renders look and my visualizations look coming out of Navisworks. Here are just a couple of examples of image renders that I did. And I know they're not perfect, but you're talking about seconds. These are images I've generated within the first minute of loading the design into Twinmotion. Here is a video. Another thing you can produce with this is a video. So here I'm recording the same data set that you saw earlier. And as I come in, our first guy is still here waiting on stuff to do. But man, it looks photorealistic right out of the package. I've added some concrete blocks to the walls, and again, I've added some additional textures here. But listen, folks, I'm still 5 minutes in to this when I generate this video. That's how fast you can do high-end visualizations with a tool like Twinmotion. Now, I'm gonna have to be careful when I say this, okay? But Twinmotion is a tool that you can actually download and use for free. The only limitation is if you want to buy it, it does give you some higher capacity outputs as far as graphic sizes. But you can go grab it and start using it right now for free. If you have questions on Twinmotion, you want to get with your IMAGINiT account manager to discuss that tool further. Now, one of the things that I have been promised for years from Autodesk is some very quick way to hop into virtual reality as far as my factory goes. Well, I have it. I didn't get it from Autodesk, but I have it. Twinmotion, it's just a simple turn on to VR, put the headsets on, and you're in here. If you can hook up your headset to your computer, you're going to be able to stand inside of this environment in virtual reality. Now, I have had customers come to me and say that their entire multi-million-dollar project hinges on getting a group of people into their environment into VR. And VR is incredibly important early on in the proposal stages, and it's never, ever been this easy to get a massive factory from the factory utilities into VR as it is now with Twinmotion. Well, listen, we are coming up on the hour, and you all have been fantastic. We've covered a lot of ground. I know that quite often a presentation like this can be very similar to drinking water out of a fire hose. I've thrown a lot of stuff at you. But I want to go over what we've discussed so far. You guys have been fantastic as far as paying attention and engaging, hopefully, with what we've shown you on the screen. But I do want to go over what we've talked about. You know, we started off this whole presentation today talking about Industry 4.0. That idea that the world has changed and all of our machines, all of our equipment, all of our products are talking to each other in new ways. Those processes need to be documented. I feel guilty sometimes, but you know, I took you guys all the way back to flow charts in analyzing a process and simulating a process. And I wanted to reiterate even again at this point how important dealing with that first dimension really is. You want to carve out a good bit of time to take care of that 1D as you simulate your process before you execute any of the CAD work. I also showed you how reality capture can be utilized in the factory layout solution. You know, laser scanners are something that a lot of us have seen really expensive scanners and really high-end companies use. Trust me, there's a scanner out there for you. And if you have questions about engaging in laser scanners, you don't have to look any further than your IMAGINiT representative. We talked about the factory design utilities and how all of them, or all the tools in the product design manufacturing collection, are used together to produce a viable solution for factory layout. And as part of that presentation, I introduced you to the asset-based workflow that I kind of called Lego CAD. I just honestly wanted to bring my little Lego figure back in here to say goodbye. We talked about VR. We talked about high-end visualizations and the factory workers that you see standing here on the screen. I generated those out of Twinmotion before the presentation started. But listen, I've covered a lot of ground with you. And the one thing I need you to understand, if anything in this presentation caught your eye, then you need to know the next thing, the next big feature of the factory design utilities, and that's IMAGINiT. That's us. We are here to help you take these factory design utilities and integrate them into the workflow that you need. Just like anybody else in the world, no one's going to need everything, but you might need to focus on just, maybe a 2D workflow with the factory utilities. Maybe you want to focus on incorporating reality capture. Get with us. Maybe you want some training on the factory design utilities. Again, come see us. Maybe you just want a trusted advisor to discuss some of the issues that you're currently having and what some of the eventual possibilities are to alleviate some of the problems you're having. Get with us. We are here to help you along your path as you move to digitally transform your factory facility into a true digital duplicate that you can use for all future planning purposes. I want to thank you all for attending today. And at this point, we want to open up the presentation for calls and questions. Thank you so much.